T4 GPU that costs $0 just trained a real 4 billion parameter model. Google hands it out for free, and you already have the code. If you want the model to know your documents or your API, that's RAG, not fine-tuning. LoRA doesn't reliably teach new facts. It bakes in a style, a format, a persona. Want better instruction following? Try prompting first. It's free and reversible. Fine-tuning earns its cost only when you need a fixed, repeatable output shape at inference time, without paying prompt token overhead on every single call. Here's the ceiling. No multi-GPU training, that's locked behind Unsloth Pro. No full parameter fine-tuning past a toy model. LoRA and QLoRA only fit this budget. Nothing near 7dB, even in 4-bit that needs 41 gig. And no long unattended runs, free Colab disconnects on idle timeout. This is a 20-minute demo, not a production training pipeline. Compute capability 7.0 or higher required, so a T4, an RTX 20 series or newer, or an A100 all qualify. Qwen 3 4B needs about 4 gig in 4-bit. A free T4 has 16 gig. That's less than a quarter used. On a Colab notebook, you don't just pip install Unsloth. The official notebook pins compatible versions of transformers and TRL alongside it, because that combo has a real, previously reported breakage history. Locally, it's one line. Create a UV virtual environment on Python 3.13, then run UV pip install unsloth with the auto torch backend flag. Plain pip install unsloth works too. Package version 2026.7.5, uploaded July 23rd. And it's Apache 2.0, the core package is fully permissive, commercial use is fine. Loading the model is 4 lines. Fast language, model.from pre-trained, pointed at Unsloth Qwen 3 4B, instruct 2507. Max sequence length 2048. And this next flag is the whole trick. Load in 4-bit equals true. That single flag is what makes a $0 GPU work at all. It quantizes the model down to roughly 4 gig instead of loading it in full precision. Full fine-tuning stays false because we're doing LoRA, not touching every weight in the model. This model itself is Apache 2.0 licensed, no gated access, no commercial restriction, rehosted by Unsloth from Alibaba's own Qwen 3 release. Normally, fine-tuning updates every number in a weight matrix. Take one attention layer in Qwen 3 4B, a 40 by 96 by 2560 matrix, 10.5 million numbers, frozen solid. LoRA locks that whole thing down. Every one of those 10 million numbers stays exactly where it started. 2 thin matrices, A and B, replace it. Trainable total, 212K, against the frozen 10.5 million, 49 times fewer. Zoom out across all 36 layers and all 7 target modules. The whole model's trainable count lands at 66.6 million. Total model size, 4 billion parameters. You're training about 1.65% of the weights. The other 98.35% never moves. The actual config is one function call. Get model, rank 32. The suggested range is 8 to 128. Target modules, Q, Proj, KDT Proj, V Proj, O Proj, Gate Proj, Up A Proj, Down Proj, all the major linear layers. LoRA alpha set equal to rank. That's Unsloth's own guidance. LoRA dropout at 0. They call it not that useful. And use gradient checkpointing set to the string Unsloth. That alone cuts VRAM by 30% and fits twice the batch size. Training data is mlabonne / finetone 100K on Hugging Face. 100K rows, about 117 meg in Parquet. Each row is a conversations column, ShareGPT style, human and assistant turns, anywhere from 2 to 62 messages. It's filtered from a larger dataset using a FineWeb EGU quality classifier. One catch, the license isn't stated on the dataset card. Fine for a demo, don't claim you can redistribute it commercially. Training itself is SFTTrainer from TRL. Batch size 2 per device. Gradient accumulation 4 steps, so your effective batch size is 8. Max steps set to 60. That's a fast demo run, not a full epoch. For a real fine-tune, you'd set numtrain epochs to 1 instead and drop the step cap. Learning rate 2E4, the standard starting point, dial down toward 2E5 for longer runs. Before training starts, train on responses only masks the loss on the user's turns, so the model only learns to predict the assistant's replies, never the question. Then, trainer.train runs. By the way, I post one of these daily. Subscribe if it's useful. Step and loss print live, ticking down each step. Watch that loss number. If it drops below 0.2 per Unsloth's own guidance, your model is overfitting. And on a 60-step run with a small batch, that's worth watching closely. Same prompt, 2 runs. First on the untouched base model, streamed live. Then the fine-tuned version. Same prompt, same streaming. Pick a prompt that shows the trained style or format, not a trivia question, because a 60-step LoRA run mostly shifts style, not world knowledge. For the actual test, Qwen's own recommended sampling is temperature 0.7, top P 0.8, top K20 for standard instruct mode generation. Saving the adapter alone is small, just megabytes. Save pre-trained writes that. To actually use it standalone, merge it back into the base weights with save pre-trained merged, 16-bit. Then, export to GGUF for llama.cp or Ollama. Save pre-trained GGUF with quantization method Q4KM. That's Unsloth's recommended default balance. Real size numbers for this model. Q4KM lands around 2.5 gig, Q5KM about 2.89 gig, Q80 around 4.28 gig versus 8.05 gig unquantized in BF16. Locally, this is 2 commands. Ollama create my fine-tuned Qwen pointed at a model file with a from line to your GGUF. Then, Ollama run my fine-tuned Qwen, and it streams responses right in your terminal. One known gotcha, Ollama's own GitHub issues confirm a bear. GGUF import doesn't always detect the right chat template, so if output looks like garbage, check that first. 3 failures show up constantly, plus 2 more worth flagging. Out of memory, one real reported case tried to allocate 9.47 gigabytes when only 3.78 gigabytes was free on a 14.75 gigabytes card. Fixes dropping batch size to 1, 2, or 3. Wrong chat template or the wrong EOS token. Both produce gibberish, always call getChatTemplate with the matching name. Loss below 0.2 means you're overfitting, cut to 1 tier 3 epochs. And Ollama's own GGUF import skips template detection, so check that first if output looks broken. Here's Unsloth's own published VRAM table, and it maps straight onto real hardware tiers. An 8 gig card, think an RTX 3060 or 4060, comfortably fits QLoRa on anything up to 8B that needs just 6 gig. A free 16 gig T4 covers up to 14B and 4-bit at 8.5 gig. Step up to a 24 gig card, an RTX 4090 class GPU, and 27B in QLoRa needs 22 gig, just inside. Go past that, and you're into 32B needing 26 gig, 40B at 30 gig, and 70B needs 41 gig minimum, even quantized. That's the real ceiling for a single consumer GPU. Unsloth's own vendor-reported numbers. The GitHub README claims up to 2 times faster training with 70% less VRAM. PyPI's package description says 2 to 5 times faster. For mixture of experts models specifically, Unsloth claims up to 12 times faster. If you tune only 4 things, tune these. Rank, 8, 16, 32, 64, or 128. Higher rank means more capacity and more memory. 32 is a sane default. Alpha, set it equal to rank, or double it. Unsloth's own guidance says both work. Learning rate, 2E4 down to 5V6. Start high, drop toward the bottom of that range only for reinforcement learning style training. Epochs, 1 to 3. Unsloth's own words. More than 3 offers diminishing returns and increases overfitting risk on typical instruction data. Got less than a T4? Unsloth ships a dedicated Qwen 3 0.6B notebook, built for phone and edge deployment through ExecTorch. Smaller download, faster training, lower quality, that's the floor, not the recommended path. And if you've got your own JSON-al data instead of FineTome, standard Hugging Face Load dataset with a JSON file works, plus a standardized ShareGPT helper if it's already in ShareGPT turn format. Everything here runs on the free, open source tier, 1 GPU, full LoRA training loop included. Pro adds multi-GPU, up to 2.5 times faster than Flash Attention 2 with 80% less VRAM. But that's a paid tier you don't need for this video. You just took a base model and gave it a fixed style on a GPU that cost nothing. That's the real ceiling of fine-tuning. Shape, not knowledge, not new facts. Need the model to know something new? That's RAG, a different video. Hit subscribe, I post one of these daily.